Okay. What is density? Um, okay. Ekuya. Oh, let me call Bushra. Bushra. What is density?
That is
Ekuya, relax.
density is mass over volume.
So, mass over volume. Density is equal to mass over volume. I want to understand further. What is mass over volume? What is mass over volume? Any further explanation? Certainly, it is the mass of the body divided by volume. But what is it? Aswani,
So please, is the mass per unit volume of the substance.
mass per unit volume of a substance. Aswani is saying the same thing, but using words. Okay. So what is it? If we talk about the density of a substance or of a body, what do we mean? What is it? Akushia.
And please, it's like the proportion of the weight of the object to the amount of substance it can hold.
Akushia, come again. The proportion of
The weight of the object
Mhm.
to the amount of substance the object can hold.
Akushia, you are saying some things right and some aspects not so clear. Okay, so when we talk about density of a substance, okay, we are basically talking about the number of particles within a given volume. Number of particles, okay, the substance has within a given volume is what density is about. In JHS, you were drawing solid, liquid, and then gases with this diagram or representing it in this form. So let's assume we have these three boxes. This represents solid, liquid, and then another box representing gas. Okay, within a solid box, you were drawing so many particles as if there is no way even between them, isn't it? Isn't it? Then for liquid, yes, some particles here, but there are holes or spaces. As for gas, as if there are no particles in a box. Okay, about 2, 3, and you are done. This is how you were modeling the state, 3 states, solid, liquid. All that you are trying to say is that if we take a given volume for all of them, solid, liquid, and gas. For solid, there are more particles within. Okay, and the number of particles talks about the mass. What is matter? Class, what is matter? Yes, I need feedback from Gloria. What is matter?
Matter is anything that has weight and can occupy space.
Okay, it has weight and can occupy space. And so what is mass? What is mass?
Maybe please, your voice was breaking. I didn't hear the question.
The question is that what is mass?
Is them
Ekuya Boatema.
Mass
Okay.
refers to the amount of substance a container can hold.
Okay, so matter has weight or mass and can occupy space. And then mass refers to the amount of what? Substance. Okay. The amount of substance simply talks about amount of particles or matter within there. So by drawing or simulating solids in this form simply means that we have more mass or matter within solid particles than liquid and then gases. So when we talk about density, we are looking at the number of particles or matter within a given volume. So if we are comparing the density of solid, liquid, and then gas, then we have to choose equal volume for all of them. Then in solids, we have a lot of particles or matter, okay, coming together to form solid, then liquid, and then gases. That's why we can conclude that the density of solid is greater than density of liquid, and then the density of liquid is also greater than the density of what? Gases. Okay, so density simply talks about number of particles or matter within a given volume. Please, class, are we okay? Are we okay?
Mr. Adrian,
Hello.
please can you repeat the definition for density?
Density is defined as the number of particles within a given volume or within a specified volume. Number of particles within a given volume or a specified volume. So we often even use the word density to describe population, density of something, okay, density of organisms. Then we are talking about number of organisms within a given area. So density isn't just about mass over volume, and that is how to calculate. Actually, using mass over volume is how to calculate for it. But when you are asked to define, you define it as the number of particles within a specified or a given volume. Is that clear?
Yes, please.
All right.
Thank you.
In JHS, you were looking at how to calculate densities of substances. Example, solids. So let's quickly revise. How were you determining density of solid? Example, regular objects. Quick one. How are you determining the density of regular objects? Yeah, Lizzie, go ahead.
Answer, please. We use an electronic scale. We measure the mass using the.
Lizzie, the question is on regular objects. We are looking at regular objects.
Yes, please.
Okay, go ahead. So you use the electronic
the
balance.
mass of the. Yes, for the mass.
Lizzie, go ahead. So we have the mass. Oh, Lizzie, your line is breaking. Okay, so yes, Lizzie is saying that we have to use the electronic balance to determine the mass. Okay, Lizzie, mute yourself for me. We have to use the electronic balance to get the mass. Then we use a meter rule or a measuring rule, measuring tape or whatever to determine the length, breadth, height of the regular object. Then we multiply these measured quantities, length, breadth, and the height to get the volume. Then we divide the mass obtained using the electronic balance by the volume, okay, determined to get the density of the substance, the regular object. If it's an irregular object, how do we determine the density? An irregular object, example, stone. How do we determine the density? Yes. Okay, let somebody else come in. Let me take the view of a different, okay. Lauren, irregular object.
Okay, so to determine the density of an irregular object, place the stone. I'm using stone as an example. So
Yes.
place the stone on a beam balance and record the mass.
Okay.
To determine the volume, tie a piece of thread around the stone. Fill 2 beakers with water. Record the first one. No, fill a beaker with water and record the volume.
Not two beakers, right? But a beaker.
Yes, please, one. Yes,
Okay.
please. Fill a beaker with water and record the volume. Place the
record the initial
please.
volume. Record the initial volume.
Record the initial volume as V1.
Okay.
Then place the stone gently with a thread into the water and record the volume as V2.
Okay.
So to find the volume, do V2 minus V1 to get the volume of the stone.
We subtract the initial volume from the final volume.
Yes, please.
V2 minus V1.
To get the volume of the stone. Then you divide the volume in the mass.
Okay. All right. That's correct. That's correct. So, the procedure is that, as she said, get a thread, a piece of thread, tied tightly to the irregular object, have a measuring cylinder filled with water, indicate the initial volume when there is no object or body, okay, immersed in the liquid or in the water. Then gently lower the stone, okay, tied to the thread into the beaker. And you are doing that gently because we wouldn't want any splash. Okay. Getting a splash can introduce error into the experiment. So you lower it gently. Okay. When the stone is immersed into the water, there will be a certain level of water will rise. Okay. So determine that volume after lowering the stone into it, and then record it as V2. Then the volume of the stone becomes V2, which is the final volume, minus V1, and that's the initial volume. Therefore, volume of the irregular object or stone becomes final volume minus initial volume. So we have V2 minus V1, and this becomes the volume of the irregular object, in this case, the stone. Therefore, density of the stone becomes the mass of stone, which we obtain using the electronic balance, divided by the volume of the stone, which is V2 minus B1. Please, are we okay? It's just a revision. It's just a revision. There is another way, another method we can also use to determine the density of substances. But in this case, it is only applied to determining density of liquids. We can only use that to determine density of liquid. As for solids, all that we have to do is, if it's regular object, what we discussed. If it's an irregular object, that is what we've done. Then, how can we determine the density of liquid? Yes, let me pick your views here before I come in. How do we determine the density of liquids? If I want, if I have cooking oil, milk, or whatever, and I want to determine its density, what do I do? Akosia.
Yeah.
How do we determine
the density of the liquid?
Yes.
Okay, to find the volume, you will pour the liquid in a measuring cylinder or volumetric bag. Then you get the volume of the liquid, and to find the mass of liquid,
Yaba, come and bail Akosia out.
Mr. Please, I think you pour the same amount of liquid that you measured in the measuring cylinder into a bottle. No, first you measure the empty bottle. You measure the mass of the empty bottle, and then you record as initial mass. Then you pour the liquid into the bottle, and then you measure the mass, and then you also record it as final mass. Then you subtract the initial mass from the final mass to get the mass of the liquid. Then you find the density using mass over volume.
But we haven't determined the volume, or you are continuing from where Akosia ended?
Yes, please.
Oh, okay. Zubia, Zubia, the last contribution from you.
Okay, sister, please, to find the density of a liquid, you use a beaker and either a burette or a pipe empty, and the beaker is also weighed plus the liquid. So when the liquid is in the beaker, you weigh it and you get M1, and the mass of the beaker is M0. And now the initial burette reading will give you the V0.
Volume.
Final burette reading will give you V1. So the volume of the liquid will be V1 minus V0, and mass of the liquid will be M1 minus V0. So giving you the density mass of our volume.
Then you take the ratio. Excellent contributions from all of you. Okay, a round of applause for yourself. Yeah, you see, all that you said, perfect, but there is a specific device for that. To determine the density of liquids, we use the relative density bottle, or what was formerly known as the specific gravity bottle. So we will use a particular device or gadget known as a relative density bottle. Formerly known as specific gravity bottle. And this is just a small bottle. We don't want to use beaker Okay, because when you use these things, great error, or we can have errors being introduced into the experiment. So we use a well calibrated and then designed something, and that is the specific, the relative density bottle. It's just a small bottle. When you come to school, remind me to show you the relative density bottle, and you'll be amazed as to why tiny it is, and then it's bearing this lengthy name. Just a small bottle. Its fine property is that it has a stopper which could fit into it and close it very well so that there wouldn't be any leakage from it. And what we do is that, as you said, you first weigh the bottle, RD bottle, when empty. When empty. So let's denote